Alright, so we are moving into 3-4 exponential and logarithmic equations, and so we are doing a whole bunch of algebra in this section. So we're going to need two big properties here. The one-to-one, where we talked about how if we have a to the x equals a to the y, we get to cross off the a's and just say x equals y, and the same thing if we have the logarithms on both sides. We get to cancel them. So from that we get the inverse properties. Same thing here. If we start with this, we get to cross off a to the log of a, and just we're left with x. And it works both ways. If the log a comes first, but then we have a, we're still left with x. We're going to use that in almost every single problem we're looking at here in 3-4. So let's start with our first example. They're just throwing up a lot of examples here. And so basically every single problem we're solving for x. What we want to do is get x by itself. And so if we look at problem A, we can rewrite 32 as 2 to the 5th. And then we get to cross off the 2's, so x equals 5. All right, same thing on problem B. We'll move the natural log of 3 to the other side, so that natural log of x equals the natural log of 3. And we get to cancel out our natural logs, and we get x equals 3. So on problem C, it's a little trickier. We need to realize that how do we flip a fraction over 1/3? We can flip it over if we put in the negative exponent, so we get 3 to the negative x. And then 9 is 3 squared. And so at that point we cross off the 3's. We get negative x equals 2, or x equals negative 2. All right. The next four are examples of using the inverse property. And so in these we have the x trapped inside of either an exponent or a log. And so we're going to get it out of there by using the opposite. So the way we'll do it is, here we have e to the x, and we want that x out by itself. So we're going to put a natural log in front of the e to the x. Now you can't just do that anywhere. If you bring in a natural log on the left side, we need to also bring it in on the right side. And so over here, what happens with the natural log of e? They cross off. And so we're left with x as our only thing left on the left-hand side, and that's equal to the natural log of 7. Which, if you wanted it as a decimal, you could plug in and approximate using your calculator. You have a natural log button on your calculator. All right, so same thing on e. We want to get x by itself, so we're going to put an e in front. And e is an exponent problem, so you'll notice here how it's e to the negative 3, not e times negative 3. The e and the natural log cancel, and so x equals e to the negative 3rd. Same thing for log problems. The only thing to remember on log with nothing here is that it's a little 10. So how do we cancel that out? We put 10 as our base. The 10 and the logs cancel, and so x equals 10 to the negative 1, or 1/10. And our last problem, we want to get rid of this log 3, so we'll put a 3 as a base. These will cancel, and so x equals 3 to the 4th, which is 81. All right, so a lot of things going on here, but really just two properties, the one-to-one and the inverse. So let's see if you can use those properties and tackle problem 17. All right, I'm assuming you're ready to go. And the first step here would be to add natural log of 2 to both sides. And so we'll have natural log of x equals the natural log of 2. Since they both have natural logs on both sides, this is the one-to-one property. X equals 2. All right, I'm going to move right into example 2. We're going to solve each equation and approximate the results to 3 decimal places if necessary. So on example 2, we've got e to the negative x squared equals e to the negative 3x minus 4. We have one-to-one function here. We get to cancel out the e's. And from here, we're just solving a quadratic. Negative x squared equals negative 3x minus 4. I'm going to bring the 0 over to the other side, make it a positive. And from here, we'll factor. What multiplies to 4 and subtracts to negative 3 should have negative 4 and positive 1, which means x either equals 4 or negative 1. All right? And so on the second one, we're going to divide by 3, get 2 to the x equals 14. And we've got the x trapped up there in an exponent, so how do we get it out of there? We're going to put a log base 2 in front of it. But if we do that on the left, we also need to do it on the right. So rewriting, these cancel. X equals log base 2 of 14. Now some of you have fancier calculators and you can plug log base 2 of 14 straight into them. Some of you will need to use the change of base formula because you only have log base 10 on your calculators, but that's easy enough to do. Log base 14, or I'm sorry, log base 10 of 14 over log base 10 of 2. And if you plug that into your calculator, you do get a decimal, but it says give it to 3 decimal places. So approximately 3.807. All right, one for you to try now. Try to get 29. All right, first step, let's cancel these e's out. X equals x squared minus 2. And so we'll have 0 equals x squared minus x minus 2. 0 equals x minus 2, x plus 1. So x equals 2, or negative 1.